Hello everyone. Today's overall topic is something called trigonometry, and specifically we're going to be calculating side lengths with something called SOH CAH TOA. Now, every year I tell my students that it is an honor to teach them trigonometry because honestly trigonometry is huge. It's useful, it's hopefully fascinating perhaps as you pursue it further. But what is trigonometry in the first place? Well, in the name, you see that there's a tri, right, or trigon. So essentially, you can think of it as the study of triangles, trigon. And indeed, trigonometry, we start with the study of right triangles specifically. But as we pursue trigonometry further, we start running into all kinds of other topics as well, such as circles. So trigonometry has something to do with circles, or weird graphs like this. See, it looks kind of like a wave. It's wavy, right? So trigonometry has something to do with waves. Or you can even make some super weird graphs like this one using trigonometry. I mean, what is going on there, right? But don't let all this make you think that trigonometry is just for making weird graphics. No, trigonometry is super useful, super important in all kinds of math and science related areas, particularly physics. In fact, I've even used trigonometry in the video games that I code and make. Now, sometimes I tell my students some of the criticisms that I have about some of the math topics that we are required to teach in school, but trigonometry is not one of those subjects. No, trigonometry is definitely one of those subjects that is worthwhile to teach and learn if you intend to go into a math or science related field. In fact, one of my teacher colleagues has said that if you remember one thing from your geometry or algebra 2 class, make sure that it's trigonometry. Although, of course, in reality, we would like you to retain as much math as possible. All I'm saying is trigonometry is one of the very significant topics that we'll learn. So let's start with trigonometry. And to start, we need to discuss the concept of similar triangles. And at this point, I hope you've worked with similar triangles in your previous work. But let's remember, what are similar triangles? What does it mean for two things to be similar? Well, here's two similar triangles. And remember, if two figures are similar, that means they have the same shape, but not necessarily the same size. So of course, these two triangles have the same shape, but one of them's bigger, one of them's smaller, right? And specifically, remember that in two similar figures, corresponding angles are congruent. So these triangles are oriented the same. So like, for example, this angle in the small triangle, that corresponds to that angle in the big triangle. So they're congruent, right? Since they're similar. And then this angle on top in the small triangle will be congruent to that angle in the big triangle. And then this angle in the small triangle corresponds to that angle in the big triangle. So those are congruent. But then what about the side lengths? Are the side lengths congruent? Clearly not, because one of the triangles is much bigger than the other one, right? So in similar figures, corresponding sides are proportional. And what that means is, let's take this side length on the small triangle. Let's call it A. That corresponds to that side length on the big triangle. Let's call it B. And then if we found the ratio between those sides, so like B over A, B divided by A, well, the sides being proportional means that we would find the same ratio for any other pair of corresponding sides. So let's say this side length on the small one is called C, and that side length on the big triangle is D. Then if we divided those the same way and found the ratio D over C, we would find the same ratio between B and A and D and C. So for example, let's say this small triangle was scaled to get this bigger triangle, right? Let's say we dilated the small triangle by a factor of, let's say, 2.5. Then when you find the ratio between B and A, divide them, you get 2.5. And that'll be the same for every pair of corresponding sides. So D over C should be the same, 2.5. Now, that's similarity for all triangles in general, any old triangle. But we start to notice more when we move on to looking just specifically at right triangles. So right triangles. Here's a right triangle, and remember, right triangle just means that one of the angles is 90 degrees, so this one in our example. And then when we study these, we notice that if we know one of the other angle measures, like let's say this is 40 degrees, we notice that this right triangle is going to be similar, as in have the same shape, as literally any other right triangle with the same angles. So here's a bunch of other right triangles with 40 degrees. These triangles on the screen here all have the same shape. They're similar. And then what people noticed is that you can actually find the same ratio within each triangle. So in our first triangle, let's look at the ratio of this side and that side, right? Well, it turns out that ratio is the same for literally any right triangle with 40 degrees somewhere. So that ratio is going to be the same as the ratio between here and there, here and there, here and there, the same for any right triangle with a 40-degree angle. And it sounds weird, but that property turns out to be super useful for calculating things. And so what people did was they started to make records, as in they started to tabulate what the ratio was for different angles. So for example, we had 40, right? And if that angle is 40, then they said the ratio between this side and that side is around 0.6428. And they did that with many, many angles. You know, we could do all kinds of angles. Let's say 30. Well, what about 30? Then the ratio is exactly 0.5. Or what about 70? 70. Then the ratio turns out to be 0.9397. And you get the idea. We could do all kinds of angles. In fact, we could do infinitely many angles. And so people made these tables, they got this info, and like I said, now we're able to use this info to calculate things. Although these days, instead of using this table, as you'll see, we'll use our calculator instead. Now, we can almost do those calculations, but before that, we need to talk about some vocab regarding the sides of the triangle. So let's do that, and note that whenever we're doing this right triangle trigonometry, we're always working with one of the angles that isn't 90 degrees. So let's just work with the angle that we've been talking about, this one right here, and I'm going to mark it with a variable called theta. Okay, this weird symbol is a Greek letter that's often used as a variable to represent an angle. So with respect to this angle that I've marked, each of the three side lengths has a special name. And actually, one of the side lengths you already know the name for, right? Remember that the side across from the 90-degree angle is called the hypotenuse. So in this case, the hypotenuse is down here. And then the other two sides. So the side that is across from the angle we're working with and not touching the angle we're working with, so across this side right here, we call that the opposite side. And then the remaining side that's not the hypotenuse, not opposite from theta, we call the adjacent side. Adjacent. Adjacent is actually a word that means next to. So notice that this side touches this angle right here, right? So again, we've got the hypotenuse across from the 90-degree angle. We've got the opposite side across from the angle we've marked here. And then we've got the side next to the angle called adjacent. And what people did is they worked with different ratios of these three different sides. So the basic ones are the ratio of opposite over hypotenuse. So this side over that side, right? That's one of the ratios. And then another ratio is the adjacent side to the hypotenuse. So adjacent over hypotenuse. And then the last basic ratio is opposite side over adjacent side. Opposite over adjacent. And so all these ratios turn out the same for different triangles if they have the 90-degree angle and the same theta here. And they gave different names to these ratios. So opposite over hypotenuse is called sine, or SIN for short. Adjacent over hypotenuse is called cosine, or COS for short. And opposite over adjacent is called tangent, or TAN, tan for short. And you may have seen these before. These may be buttons on calculators that you've worked before. And so those buttons will tell us what the ratio is for different angles. Now, that was a lot of information all at once, and it might be kind of overwhelming. So let's just look at an example and see how this type of calculation goes. So here we've got an example, calculate the value of x, and it's a right triangle, so we know we can use this trigonometry stuff. And first of all, notice what the angle that we're working with is. So where's the non-90-degree angle? It's here, right? And so we're working with a 32-degree angle. Next, establish what sides we're working with relative to that angle. So the sides that we're working with are this x that we don't know, but we're trying to calculate, and then this 28, right? So we're working with those two sides, and we need to figure out, are those sides opposite, adjacent, hypotenuse? What are they? Well, hypotenuse is easy. Hypotenuse is across from the 90-degree angle, so this 28th, that's the length of the hypotenuse of this triangle, right? What about the other side? What about x? So we've got the hypotenuse down. Is the x touching the angle? Is it adjacent? Or is it across from the angle? Is it opposite? It is across. So your x is the opposite side, right? And what you do is you have to look at the sides you're working with and pick which ratio matches those two sides. Because we've got these ratios here, there's three of them. And you ask yourself, well, if we're working with the opposite side and the hypotenuse, is it sine, cosine, or tangent that uses those two sides? And it's the first one, right? It's sine. It says sine is opposite divided by hypotenuse. Once you figure out your ratio, you can set up an equation. And how it goes is you write, okay, sine, S-I-N, of the angle we're working with, 32 degrees, equals opposite over hypotenuse. So in our example, opposite is x. Make sure you start with the right one. It says opposite on top, so we start with x divided by hypotenuse, so that's 28 on bottom, right? And there's your equation. And so again, this ratio between the sides, x to 28, that has something to do with the sine of 32, right? And this is where our calculator comes in. What you do is in your calculator, you should find a sine button, and you're going to type in sine of 32. And you should get that this whole thing is around 0.5299. So that is the ratio of these sides, x over 28. And then how do you get the x by itself? Well, it's being divided by a 28, so you multiply both sides by 28, right? These go away on the right side, and you get x alone on the right side equals 28 times whatever that ratio is. So you do 28 times what you got from sine 32, and you'll get around 14.8377. And that is our answer. That's the side length. And so that's how these calculations go. By the way, you may have used the calculator to get sine 32 and gotten something different here. That's because calculators have two different modes. So you have to make sure your calculator is in degree mode for the problems we'll be doing. And later in this video, I'll show you how to do that with one type of calculator. But most calculators should have its own way, different for each calculator, of switching between different modes. And again, for all these calculators, for our problems, you're going to be wanting to use degree mode. So let's do another example. It says, what is the value of y? That's a side length on a right triangle, so we can use this right triangle trigonometry, right? And again, first of all, where is the non-90 degree angle that we're working with? Well, that's here, the 53 degrees, right? And then relative to that 53 degrees, what are the side lengths that we're working with? So we got a side length here and a side length there. And which side lengths are they? So again, it looks like we have the hypotenuse across from the 90, so this y is the hypotenuse. What about the 17? Is it across from the 53 or next to? Is it touching the 53? It's next to, right? It's touching. So this is what we call the adjacent side. So we've got two sides, they're adjacent and hypotenuse. So now again, pick the right ratio out of the three. Which one uses adjacent and hypotenuse? Well, that's the middle one, cosine, right? Cosine is adjacent over hypotenuse. So then set up an equation. We write cosine of the angle we're working with, 53 degrees, equals, and then it tells us adjacent on top, so 17 on top with hypotenuse on bottom, so y on bottom. And here we have to be careful. How do you solve an equation when the variable is on the bottom? And so first, let's figure out what this ratio is, cosine of 53 degrees. So again, plug cosine 53 degrees into your calculator. Make sure you're using degree mode, and you'll get around 0.6018, and that is around 17 over y. Now, one problem here, how do you solve an equation when there's a variable on the bottom of a fraction? So let me rewrite this equation here. 0.6018 is around 17 over y. And we want to get the variable by itself. What do we do first to both sides? Well, if a variable is on the bottom, we want to get it out of there. So you multiply both sides by the variable, right? Multiply by y on the left side, y on the right side. And the variables, this is times y divided by y, so they cancel over here. And then what do you have left? Well, on the left side, you have y times this weird number, 0.6018. So you'll have 0.6018 times y. And then that is around. On the right side, the y's cancel, so all you have left is 17. So now we got 0.6018 times y is around 17. How do you get the y by itself? Well, now we just have to divide by that weird number, right? Divide both sides by 0.6018. Divide the other side by 0.6018. These go away. On the left side, we finally got y by itself. And then on the right side, just plug that in your calculator. What is 17 divided by that weird number? You should have gotten something close to 28.2486. And that's the value of y. That's our final answer. That's side length. So that's the only type of problem we'll be covering in this lesson, but I think you've seen that it's super important that we know these ratios here, right? So what I want to point out is there's this way to make it easier to remember these ratios and what they mean. And it's called SOH CAH TOA. Now, what is SOH CAH TOA? Well, if you look, the letters in this SOH CAH TOA corresponds to the information in these ratios over here. So look, so that's SOH, right? Well, S stands for sine, and the sine of an angle, theta, equals, and then O, that stands for opposite. So opposite divided by, and then the H stands for hypotenuse, right? Hypotenuse. So says sine is opposite over hypotenuse. What about CAH? So CAH. That means C for cosine of an angle equals A is adjacent divided by over H on the bottom, hypotenuse. And then finally TOA, T-O-A. That of course is T for tangent of an angle equals O and then A. So O for opposite over A for adjacent. And so this word, again, is meant to help you remember what these three ratios mean. So that's mostly it for today. If you had trouble with sine, cosine, and tangent in your calculator, keep watching and I'll show you an example of changing the mode in your calculator. So here's a scientific calculator, and to make sure that your mode is correct, you would use this DRG button. So you press that button and it shows you these three options. And this first one, DEG, stands for degree. And you want to make sure that one's highlighted, not these other two. And if it's not the right mode, go over to DEG, press enter, and that'll be the correct mode for today. And if you look, there's these little letters over here that tells you what mode it's in currently. And that's how you would change modes on this particular scientific calculator. Again, for different calculators, there's different ways of doing it. You may have to experiment and try to figure out where that option is. Good luck, and as always, if you have questions or feedback, feel free to contact me.